Nak tahu kelajuan peranti pintar dalam 5G? Di MMU ada jawapannya. Nak tahu bagaimana kandungan kreatif dan perniagaan atas talian dikuasai? Di MMU ada jawapannya. Nak tahu bagaimana cyber security dan undang-undang berfungsi? Di MMU ada jawapannya. Semua itu dan banyak lagi ada di Multimedia University kerana MMU ialah anda menerajui masa hadapan digital. Layari mmu.edu.my.
Yes, Assalamualaikum warahmatullahi wabarakatuh and good morning to all viewers and participants. Okay, today we're going to have another session of KLESF sharing session with the Faculty of Engineering and Technology. So I'm Fazly from Faculty of Engineering and Technology, and today I'll be going through perhaps in 2 to 3 hours on how to have fun with robotics. Okay, using a simulator we call VEXCode VR. Okay, so I'm sure most of you know what robotics is. Okay, so it has been one of the um, emerging technology for many years, and of course, going to the future, robotics would be one of the directions um, in various industries. Okay, so today we're going to learn a little bit about how to an introductory to robotics, particularly looking into how robotics is robotics how learning robotics can be fun lah. Okay, robotics, we can start learning robotics using simulators to start with. Okay, but before I start, let me just acknowledge my students from the MMU Robotics Club who has helped me in developing the slides, okay, for this session. Okay, so they are part of innovative students from the Faculty of Engineering Technology who have been working a lot on robotics related projects. Okay, so basically we're going to go through several sessions today, looking into the basics of programming and programming languages. Okay, what is a programming? What is programming exactly? And then introduction to VEXCode VR, okay, a simulator for robotics, and what are some of the applications in the real world. Okay, and then we're going to do some fun exercises. Okay, so you can actually participate as well in the exercises because we're going to use a free VEXCode VR simulator in which you can just access it through the a browser. Okay, later on I'll share the codes with you, the URL with you. Okay, so just before we go into the details, let me just show you some of the examples of robots. Okay, I won't go through the sophisticated robots, but just a simple example of robots, because knowing robots, there are two major parts of robots. One is the hardware component, and the other one is the brain of the robot. Okay, so the programmable component of the robot. Okay, so any hardware, robotic hardware, we need to give it some instruction for it to work. Okay, so for various purposes, for various applications. So it's very, very important to know these two parts. Okay, one is the hardware component, the mechanical component of a robot, and the second part would be the brain. Okay, the programmable component of the robot. Okay, so it's a processing unit, or it's the brain lah, basically. Okay, so these are just some examples of which is designed for different for specific purpose. And our student university has been doing this sort of project in order to increase their awareness of how to build and creatively design a robot for a specific purpose. So this is one of an example of a robot which is designed to be a rescue robot to maneuver itself within a small area. Okay, for instance, if you have a disaster area, you want to deploy a robot, okay, into disaster areas, you need to make sure that the robot is designed specifically for that purpose, considering the environment around it. Okay, and these are just also some other robots that we use. And this is one of an example of a mobile inspection robot that goes into an oil pipe. Okay, so can be used for oil and gas industry or any other industry which is relevant. Okay, so in this case, the robot is equipped with some sensors to so that it can navigate itself within a small area, tight area, and the robot can be controlled using a remote control, or it can also maneuver itself using different sort of sensors. Okay, and of course another robot as well which can operate underwater or on the surface of water. Um, and all these robots require some degree of program to give its instruction of what to do, how to work, what are the function that it needs to accomplish. Okay, so this is basically what the world of robotics is. Okay, so if we look at the current uh, diverse nature within the industry, we have industries such as manufacturing, we have an industry such as oil and gas, even if you go to warehouses, Lazada or Shopee, they also use some degree of robotic equipments to help them in the warehouses. Okay, so a lot of industries nowadays use robotics in various nature. Okay, so these are also some other types of robots. Some robots, we cannot think of robot as being just humanoid or human-looking robots. Okay, some robots are not human look. Some could be try to imitate the movement of animals. Okay, for instance, like the one I showed just now, ill-shaped robot. Some, of course, looks more or less like humans. Okay, but not all robots are humanoid in nature. Okay, okay. So these are some of the robots in order to give you some sense of what the robotics world is all about, lah. Okay, so and very important to know that in order for us to understand how to design robots, one of the first steps is to be able to create instructions for the robots. So how do we create instructions for the robot? We need to program the robots. Okay, such as ourselves as humans, we need over time some instructions or some learning stage in our life. Okay, when we are infants, we learn how to eat. Okay, how to walk. Okay, the same with robots. We need to give them instructions, or we need to give them some commands for them to accomplish the task that we want them to do. Okay, for instance, in the case of programming, okay, programming is some instruction that we provide to the robot or to the computer, to the machine. So in this case, you want to know or want to give the robot to understand what they need to do. Okay, in that sense, we need to use some programming languages. The popular ones, of course, C++, Python are some of the programming language. Of course, Visual Basic, COBOL, Perl, Fortran, so on and so forth. Okay, so to a certain degree, you might have already been exposed to some of them. Okay, so programming skills is very important when it comes to designing a robot. Okay, and when we talk about programming languages, okay, we have machine language. Okay, we also have other type of programming languages such as Python, C++, C, Java, so on and so forth. Okay, so these programming scripts will be giving the machines instruction of what to do. And to talk about more advanced machines or robots, to a certain degree, they can evolve in the sense that they can learn, okay, using machine learning algorithms. Okay, and when they experience some learning process, the robots will get more intelligent through time. All right, so this is the importance of programming languages when it comes to the design of robots. Okay, so basically, as I mentioned just now, programming language is used to tell the robot the instructions. Okay, so in this particular session today, of course, we only have 2 to 3 hours, so there's not much detail to go through, but I'll just go through one block-based programming approach, which is called VEXCode VR. Okay, which is free for use. Okay, later on I'll show you how to access the the website, and you can also practice along with me later on at later stage. Okay, so it's very easy to program. Okay, you just need to assemble some blocks and give it some instruction, and you're going to see the results. Okay, as you run the code. Okay, so it's basically a step-by-step block where you can rearrange the blocks based on what you want the robot to do. Okay, so this is showing you one example of the VEXCode VR. Okay, so you can go ahead, and if you're watching this through browser, you can actually go ahead and key in the following URL, vr.vex.com into your browser, and you can access the simulator straight away. Okay, so you're going to see the interface, which basically comprise of the blocks that you can utilize for your code, as well as the playing area, okay, or the canvas. Okay, so maybe I'll just show you a quick view of the interface. Okay, so this is the simulator, VEXCode simulator. Okay, so you can see on the left hand side here all the blocks that you can utilize in order to create the instructions for your robot. Okay, so basically there's a drive train, okay, basically to move the robot in certain directions, whether it's forward or it's reverse. And then there's a magnetic function whereby you can program the robot in such a way that it can pick up certain components, okay, from the ground. And then there's also other functionalities for the robots, okay, based on the blocks that you select. Okay, of course, I won't go through everything today because there's quite a lot, so I encourage you to explore them when you have the time after the session. Okay, so as you can see, there's a lot of classes of codes that we can include in our simulator. Okay, control, we have the sensing class. Okay, so sensing is very important when it comes to the design of robots. Then the operators, and then we have the variables that you can define, and you can also design your own block. Okay, if you want to design something which is not listed here, okay, in the pre-listed blocks, okay, you can also design your own blocks. Okay, on the left hand side, on the right hand side, we have the space for you to add the blocks into. All right, so this is just a snapshot of the VEXCode simulator. So later on, we'll go into more detail, okay, when we start doing our exercises later. Okay, let me just go back to the slides. Okay, so so this is a simulator that we're going to work on together today. So we're going to take some short time to practice the codes so that you get a hands-on feel of how to generate, or how to generate the codes and instructions for the robots. Okay, so this shows the virtual robot that we're going to work with. Okay, so basically the robot is equipped. Okay, so it's a virtual robot. So basically the functionalities of the robot, you can imagine it being a real hardware, okay, but it is in a virtual form. So basically you have the robot with these functionalities. First of all, it's electromagnet. Okay, it has a magnetic component here that can be used to pick up metals on the ground. Then we have a pen. Okay, so basically the pen is used to draw a line on the surface where the robot moves onto. And then we have the sensors, left and right, the bumper sensors, which is meant to, okay, so this is the right bumper sensor and the left bumper sensor, basically to detect any collision or any touching action with with what it encounters physically. Then we have built-in gyroscope and plus location sensor. And then it also has a front eye and distance sensor. Okay, basically to give it the eye functionality where you can see. Okay, more or less like a camera function. Okay, so this is our virtual robot, which we will be using later on. Okay, so in this session one, we'll see how we can simulate the robot using some basic movement and also using some basic rotation functions. Okay, and then we'll also learn how to draw shapes using the robot's pen functionality. Okay, so there's a pen function here. So this pen can be used to draw shapes on the ground. Okay, so this shows one example of the code and the canvas that we can later on use to draw the shape on the ground. Okay, so depending on your specifications for the angle and the movement, whether it's forward or reverse, okay, you can draw different shapes using the virtual robot. Okay, so before we move on into the hands-on exercise, so um, let me just go through some of the basic functions. Okay, what are different blocks representing? Okay, so there are different blocks in the simulator. So basically, we have what is known as the head block, which is basically used to start the simulator or to start the instruction process. Okay, so it starts the stack of blocks and are shaped to attach blocks below them. Okay, if you can see, there's a slight extrusion here, the markings under this yellowish block. Okay, so this is meant to attach it to the incoming block, okay, at the bottom. Okay, so that's the start block or the head block. Okay, we have then the stack blocks. Okay, stack blocks basically perform the main commands for the simulator, okay, for the instruction. And basically they are shaped to attach blocks above and below it. Okay, for instance, you can see here you have an instruction to move robot pen. Okay, so basically the instruction here is to move a robot pen either down or up. Okay, meaning that if you move the robot hand down, the robot will actually draw something on the surface of the canvas. Okay, and other sort of stack block example would be stack block that instruct the robot to drive forward for a certain distance, for instance 200 millimeters, or turn right for 90 degrees. Okay, so these are examples of stack blocks. Okay, and then we have Boolean blocks. Okay, Boolean blocks is a block that gives certain or return a condition as either true or false. Okay, so Boolean here means 0 and 1 lah, basically, whether it's true or false. If it's true, then it's 1. If it's false, then it's 0. Okay, so it tries to fit itself inside any blocks with hexagonal input from other blocks. Okay, for instance here, we have a Boolean block that says left bumper pressed, okay, with a question mark, meaning that is the left bumper being pressed or is it touching something? Okay, so this is one example. So if it touches something, then it returns a 1. If it doesn't touch anything, then it returns a false or 0. Okay, and another example is wait until left bumper is pressed, meaning that the robot will wait until the left bumper is pressed, then only it's going to do something. Okay, so this is an example of a Boolean block. An easy way to think of it is the output is either 0 or 1, false or true. Okay, for instance, if I ask you a question, have you eaten today? So your answer would be yes or no lah. So just two different answers and no other answers possible. Okay, reporter blocks report values in the form of numbers and fits in any block with oval inputs for other blocks. Okay, for instance here, you have distance in millimeter. Okay, so it will take the distance in millimeter and round it to the closest integer. Okay, so it fits into another block. All right, so this is one example of reporter block. And then we have the C block. Okay, the C block is commonly used for loops. Okay, so if you don't have any programming background yet, okay, a loop is a process that repeats itself depending on how many times we want it to repeat. Okay, for instance, you want the robot uh, to move back and forth 10 times. Okay, so you can repeat the process 10 times, meaning that you don't have to uh, repeat the code multiple times. You just use a loop, okay, in order to repeat the process. Okay, for instance, if we revert to this example here on the right hand side, if the left bumper is pressed, then turn left for 90 degrees. Okay, so this is one example of an if statement. Okay, if statement means that if a certain condition is fulfilled, then it will do something. Okay, in this example, if the left bumper of the robot touches something or hit the wall, then it will turn itself to the left hand side as much as 90 degrees angle. Okay, so this is one example of C block. Okay, it's called a C block because you can see the shape looks like a C. Okay, that's why it's called a C block. Okay, a C block can be a loop or it can be an if statement, while loop, and so on and so forth. Okay, so these are the basic examples of the different block shapes when it comes to the VEXCode VR simulator conventions. Okay, so this one shows a more detailed example of the different blocks. Okay, so we have the head block here, which always starts at the top. Okay, it's always at the top because it signifies the starting of the process of instruction, okay, to the robot. Okay, and then we have the stack blocks. Okay, so it performs commands such as to move the robot pen or move the robot forward or backwards or reverse. Okay, so this is one example of it. Okay, later on we'll do some practice on this one. Okay, Boolean blocks, if else, no, sorry, true or false. Okay, 1 or 0, and it fits inside any blocks with hexagonal. Okay, hexagonal means this shape here. So you can fit this hexagonal Boolean blocks into those into that hexagonal shape. Okay, in order to put it into the if statement or the for loop or whichever C block which is applicable. Okay, so in this case, if you look at the code on the right hand side here, when you start the code, it will actually implement or check if the left bumper of the robot pressed, then it will repeat a certain list of process. Okay, for instance, moving the robot pen down or drive the robot forward as much as 400 millimeters. Okay, so this is one example of the Boolean blocks. Okay, reporter block, as I mentioned earlier, it fits itself inside any block with oval input for other block. And the C block, of course, for loop, if statements are all part of a C block. Okay, that checks the condition of whether it's true or false. And we have for loop, we have a loop that actually repeats processes in order to have a more efficiently written code, so that you don't have to hard code the script in order to repeat certain actions. We just use a loop. Okay, and if you refer to the simulator, there is a functionality for you to actually learn more about the blocks. Okay, so you just have to select a block and see more information. Okay, there's a help functionality for you to actually learn more about the blocks, because there are so many blocks here. For instance, if I click on when started, you can actually see the description of the block in order to understand what it actually does. Okay, if I look at the sensing block, I click on one of them. Okay, let's say reset timer. Okay, you're going to see what does the block actually do. Okay, so reset timer here, for instance, begins at the beginning of each project, and the reset timer block is used to reset the timer back to 0 seconds. Okay, so this is one example where you can get the information or the resource for you to understand more, okay, about each of the block which is used in this VEXCode simulator. Okay, so I can proceed um, with the next part, which is looking at an exercise. Okay, so it's very important for you to exercise or to practice coding. Okay, because coding cannot just be learned by reading textbook. Okay, you need to practice. You need to really solve problems hands-on using programming skills. Okay, first of all, let's try a very simple example. And this example would be to move and rotate the robot. Okay, very simple movement first. And the requirement are as follows. Try to design or instruct the robot to move in the following direction. Okay, first of all, straight line for 400 millimeters. Okay, it's very specific. The distance is given 400 millimeters. Then reverse for 400 millimeters. And then turn to the left side. Okay, to turn to the left side 90 degrees. Drive forward for 200 millimeters. And turn to the right 180 degrees. Drive forward 200 millimeters. Okay, so it's very specific. So let's try this. And if you have access to your browser now, if you're watching from your desktop or from your laptop, you can actually join in and practice this together. Okay, so basically the exercise is for us to achieve this particular shape. Okay, it's a square. Okay, let's open up the VEXCode simulator, and let's try do this. Okay, first of all, of course, you need the canvas. So what you can do is open up the playground. Okay, so there are multiple playgrounds that you can actually experiment with. If you click on select playground, you can see there's a lot of playground that you can play with, and we'll start from the simple one, which is using this art canvas here. Okay, this art canvas. Okay, so it will load the playground. Okay, so you can see the playground loaded. Okay, so what you can do is you can start dragging the relevant blocks. Okay, so what we need to do is make sure that we have the relevant blocks used for this simulator. Okay, so you can see we already have our starting block and our ending block, okay, which will signify when to start and when to stop driving. Okay, next we need to make sure that we have our pen ready. If we don't have, or if we don't specify the pen here, our pen won't be functioning. So we need to make sure that we have our pen ready. So okay, let's look for the pen. Where is the pen? Okay, there are quite a lot of functions here that you can play with. Okay, let's look for the pen. So we need to move the pen downwards. You can see here. Okay, just drag it. Okay, move pen down. Okay, meaning that you're going to move the pen downwards so that the pen will start drawing on the canvas. Okay, so next we need to be able to move the robot once the pen is set down. Okay, to draw on the canvas, we need to drive the robot forward. Okay, so we can select one of these. Okay, so drive forward for 600 millimeters. Okay, so just go ahead and change this to 600 millimeters. Okay, and what's next? Okay, so when it moves forward, it will move forward as much as 16 millimeters in distance. Okay, next we have to turn right. because we need to form a square. Okay, turning right, we require us to use this block. Okay, turn right 90 degrees, and then, okay, a quick way to do this, you can also duplicate. Okay, just right hand click and duplicate, and then it will duplicate the exact block. Okay, and then you can, okay, if you want to duplicate these two, let's say you have these two which are similar, you want to repeat these two process. Okay, you can duplicate both of them. Okay, just duplicate this one first. Okay, you can see you can duplicate two blocks at the same time. Okay, so you just select forward, drive forward for 600 millimeters, and then turn right for 90 degrees. Okay, you want the robot to turn right in order to form a square. Okay, what is next? Okay, duplicate again. Duplicate. Okay, and again 600 millimeters forward and 90 degrees turn to the right. Okay, so now I guess we should have 4 lines already. Okay, 1, 2, and 3. Okay, we need another one. So we just duplicate again, one more round. Sorry. Duplicate. Okay, now the same blocks are created and turn 90 degrees. Okay, so I guess it should end there. So you just stop driving at this point. Okay, so now we have our instruction ready. Okay, so to simulate this, just click here on top, start, or you can click down here on the canvas itself. Okay, where you have the triangle button there. Okay, just start to simulate. There it will actually draw the square. So this is very simple example just to show you how this can be done, how the instructions can be given to the robot. Okay, you can stop this and then you can reset it. Okay, so if I just modify this a bit and use up instead of down, I think you can guess what the effect would be. Okay, the robot wouldn't be drawing anything because the pen is currently pushed up. Okay, it's not touching the canvas. Okay, so that is one easy example lah. Okay, you can go on and perhaps change some of the angles and just you can see what the effect would be on the movement of the robot. Okay, so you can see the movement is different this time. Okay, and if I put the pen down, reset, okay, you can see the movement. So it's moving in a different formation. Okay, so that's a very simple exercise to show how the instruction can be given to the robot. Okay, so we can move on to the next part. Okay, so I hope everybody's okay with this. Okay, it's a very simple example. So you have, as I mentioned earlier, if you have access to VR to your browser, and you're not watching this from your mobile phone, you can try it out together with me using the VEXCode VR simulator. Okay, for you to have fun with it, as I mentioned earlier, there are quite a lot of playground that you can explore. Okay, if you click playground here, you can see a lot of other playgrounds that you can work on, and of course you need to come up with different instructions to accomplish certain things for the different playgrounds. Okay, so we have done this already. So we get the square. So after this, we'll work on something more difficult lah. Okay, So exercise number 2. Okay, exercise number 2, draw a single shape using the robot pen. Okay, so it's the same exercise except that in this case we use a different shape. Okay, the output is different. Okay, if you can imagine the robot having to solve a certain problem in a manufacturing plant, obviously depending on the setup in the manufacturing plant, you want to instruct the robot to do different things. Okay, so in this example here, just now we draw a square. So now what happens if you want the robot to draw a triangle instead? Okay, for instance, a triangle with a side of 200, 300, and 400 equilateral triangle. Okay, so we need to make sure that we have the correct specifications, okay, for the triangle. Okay, so let's try one example here. Okay, again, we need to open up our simulator. Okay, you can go ahead and modify the instruction that you have used earlier, or you can just delete the blocks and start over again with new set of blocks. Okay, depending on your preference. Okay. Now our task is to build or to draw a triangle instead of a square. So how do we do this? Okay, so by the way, if you, I've already shared the slides in shared Google Drive. So if you can scan the following QR code, and the URL is also given here. Okay, you can get access to the slide that I'm using. Okay, so either scan or you can use the URL specified down here. Okay, I leave this to you for a while to have a look, to download the slides. Okay, so now let's start drawing the triangle using some simple sets of instructions. Um, okay, let's open the simulator again. So here you can see the canvas, and the robot is already at its ideal location. Okay, so now try giving it an instruction to draw a triangle. Okay, so how do we do this? First of all, of course, you have the starting point, and then you have to make sure that the pen is down, and then you have to set the uh, okay, I'll show you some other extra blocks that you can use. Okay, let me just clear the set of blocks first. Okay, just keep these two blocks when started and stop driving. Okay, so you can set the robot pen to a certain color actually if you want to explore a little bit more. Okay, set the color. Okay, let's say you want to use a red color instead of black. Then you move the pen down. Okay, and then of course you need to either move the robot and or turn the robot. Okay, so you can turn the robot first to a certain degree, perhaps turn left for 150 degrees because we are trying to form a triangle here. Okay, and then drive forward for 600 millimeters. Then we can turn left. Okay, you can just duplicate the one that we already have just now. Sorry. Oh, sorry. Drive forward for 600. Then turn to the left 420 degrees and drive forward for 600 millimeters. Then turn left for 120 degrees and then drive forward for 600. Okay, so one important element of programming is to be able to troubleshoot. Okay, so let's see if our code is working fine. If it's not, then we have to troubleshoot lah. Okay, meaning finding what's the error and try to rectify the error. Okay, so let's try and go ahead and run this and see whether it's performing what we want it to do. Okay, so it's able to form the triangle, but the problem is it's using black instead of red. Okay, so there's something wrong there in which we need to troubleshoot. Okay, so how do we troubleshoot that? Okay, so we need to make sure that the color here is the right color. Okay, let's just change that to green and see whether it's doing the exact thing that we want it to do. No, it's still using. Oh, this one is using print. No wonder. Okay, so that's why you need to be careful when you code. Make sure that you use the right block and use the right syntax. Okay, so in this case, we're using set print instead of set pen color. So we need to remove that and make sure that we use the right block. Okay, set pen color. So this one is the correct one. Okay, so it's very easy for us to mistakenly use the same block. Okay, so here we can change the color accordingly, depending on what combination of color you would like to use. Okay, let's say I want more purplish looking line. So just reset that and go ahead and run the code. Okay, now it's using the right color. Okay, so that's why troubleshooting is one important part of coding as well, in order to rectify a problem in your code. Okay, all right, so I hope everybody's clear on that one. That's pretty much a very simple process of instruction giving to the robot. Okay, we're going to take a break for a while. And in the meantime, okay, you can either get coffee or eat something, or you can also test out the codes that we have gone through just now. Okay, so we'll take a break for a few minutes before we get into section 2 of the session today. Okay, see you later.
Nak tahu kelajuan peranti pintar dalam 5G? Di MMU ada jawapannya. Nak tahu bagaimana kandungan kreatif dan perniagaan atas talian dikuasai? Di MMU ada jawapannya. Nak tahu bagaimana cyber security dan undang-undang berfungsi? Di MMU ada jawapannya. Semua itu dan banyak lagi ada di Multimedia University kerana MMU ialah anda menerajui masa hadapan digital. Layari mmu.edu.my. Nak tahu kelajuan peranti pintar dalam 5G? Di MMU ada jawapannya. Nak tahu bagaimana kandungan kreatif dan perniagaan atas talian dikuasai? Di MMU ada jawapannya. Nak tahu bagaimana cyber security dan undang-undang berfungsi? Di MMU ada jawapannya. Semua itu dan banyak lagi ada di Multimedia University kerana MMU ialah anda menerajui masa hadapan digital. Layari mmu.edu.my.
Welcome back. To welcome back to session number 2. So just now in session number 1, we have seen the basics of the simulator and how we can draw different shapes using the simulator. Okay, so in this second session, we'll be looking into how to construct loops. For your information, instead of having to repeatedly use different blocks, similar blocks, we can actually loop the blocks in order to accomplish repeated actions, okay, and instruct our robots to do an action which is repeatedly done. Okay, so in this case, in session number 2, we're going to go into the introduction to loops. Okay, so if you have basic programming, you would know what loops are. Of course, in terms of the syntax, if you write the scripts in C++ or C, Java, okay, there are standard scripts or syntax as to how you write loops or how you construct loops. Okay, but we're going to see in this simulator how do we use loops to repeat certain processes. Okay, so these are the things that we're going to cover. Okay, we'll end our session 2 with some exercises as well, some fun exercises for you to be able to implement loops in your code. Okay, so we're going to have a look at the types of condition selection, the types of loops available, and then how to convert text codes to block codes, or vice versa lah, from block to text or from text to block. Okay, so the types of condition selection. Okay, so as I covered this in the first session, in terms of the types of condition selection, okay, we can use if statements. So if statement is a condition or is a condition where we want to check certain factors. Okay, for instance, if I give you one real life example lah. Okay, if it rains, I will just play games in the house. Else, I will go outside and play football, for instance. Okay, so there's if and else. If this happens, then what you do, and if an opposite thing happen, then what you do. Okay, so it's an if and else statement lah. So that's what we call an if else condition loop. Okay, so situation that need to consider, where we need to consider external factors or arithmetic or logical conditions. Or situation where we have to consider this. Okay, so the output of if else condition will be true or false. Okay, if this happens, then I do this. If else, I will do something else. All right, so that's the if and else condition. Okay, so here's one example. When your code starts, you check if the distance found an object. Okay, if the robot finds an object at a certain distance, then you knock over the building found using a distance sensor, for instance. Okay, just an example. And then you drive forward. So this is the action that will happen if you find an object at a certain distance. Okay, if distance sensor detects an object, output is true, so you drive forward. Okay, so it gives the robot an instruction of what to do if it encounters something. Okay, else if the object is not sensed, okay, if the robot doesn't sense any object, what it needs to do is turn to find a building using the distance sensor. Okay, so if it doesn't have an object in front of it, it turns and it tries to find another object or turn right. Okay, so these are the instructions given to the robot. If and else. If something happen, do something, else do something else. Okay, so that's the condition. Okay, and then we have loops. Okay, just now is the if and else statement. Now is looping. Okay, so looping is also one example of a C block, meaning that we need to repeat certain processes many times or certain times depending on our specifications. Okay, for instance, in the example given on the left hand side, repeat 10 times a certain action. Okay, for loop with number is specified here as 10, repeat code for 10 times. Okay, and infinite loop will be repeating the code infinitely until we instruct the code to stop. Okay, so that's infinite loop, meaning that it doesn't have any condition, it just says loop forever. Okay, so these are two examples of loops. Okay, and there's also a looping functionality that use repeat. Okay, repeat until. Okay, so it repeats the instruction until a certain condition is met. Okay, for instance in real life, okay, repeat eating until you are full. Okay, it's the same example here. Repeat something until a certain condition is met. Okay, meaning that the one example, okay, robot have to move until it stumbles over a wall or something. Stumbles on the wall. Okay, one example. And then there's a while loop as well. Okay, while loop is repeating a process also until a condition is met. Okay, so these are the two different types of loops. Repeat until and then while. Okay, so in order to better visualize or practice the what we have learned just now, if else condition as well as the loops. Okay, let's try one example. Okay, so this example here is has the following specification or objective, which is to push these blocks. Okay, there are 5 different types or shapes of blocks out of the map. Okay, so the canvas specified, where the border is specified by the red lines, are actually the vicinity of the playing field. What the robot has to do is to push the blocks out of the canvas. Okay, meaning that it shouldn't be within this red boundary lah. And the robot itself must remain in the map. Okay, so how can this be done? Because if we move the robot, there is a possibility that the robot will itself move outside of the area. outside of the map or the playing field. So we need to specify certain conditions that will make sure that the robot doesn't move out of the playing field. Okay, using the information that we have about the red color wall or barrier over here, and it needs to be able to push all the blocks out until there's no blocks left in the playing field except for the robot itself. Okay, so this is the task or the objective given here. Okay, so how do we solve this problem? Okay, so let's work on this for a few times. So this is the final result which we are expecting. The map without any blocks. What's left is only the robot inside. Okay, so let's try this. Okay, so this is a solution given. So we can have a look and see whether this is working. It might not work. As I said earlier, it might not work. So we need to troubleshoot. So let's try this together. Let me just open up the simulator again. Okay, so in this case, we need to open new playground. Okay, select a playground and you have to look for the, which one is it? This one, Castle Crasher Playground. Okay, down here, there's a Castle Crasher Playground. So go ahead and select that and we'll wait until it finally loads. Okay, so this code may take a while for it to execute, so we need to be a little bit patient here. All right, so you can see the exact same playground has been loaded. So just delete our previous code to prepare ourselves for the new set of codes. Okay. So first of all, the concept behind this is to make sure that the robot stays within the playground, and at the same time, it will gradually push all the blocks out. Okay, so by not using any sophisticated sensor, we can try to move the robot randomly around the canvas and hoping that at every single movement or at specific movements, it will push the blocks out. Okay. For information, there's many ways to do this. There's a simple way and there's a more sophisticated way. So it's free for you to explore. But for the purpose of our exercise today, I'll just show you one example of how to do it. Okay, so first of all, perhaps we can set the robot to move. Okay, we can set the driving velocity to 100%. Make sure that it moves fast because you want to make sure that the blocks are removed as quickly as possible from the canvas, from the playing field. Okay, we set the drive velocity to 100% of the robot's capability. And then we set the turn velocity to 100% as well, meaning that the turning velocity, the velocity at which the robot turns, we also set to its 100% capability. Okay, so the next stage would be the part where we will loop the robot movement. Okay, so we have already set the velocity and the turning velocity to 100% each. So now what happens after that? Okay, we need to make sure that the robot moves in a certain way, in such a way that it doesn't exit the playing field, and at the same time, it will push the blocks out of the playing field. Okay, so we can use an if statement. Okay, so let's check. Can use an if else statement, or we can use a loop first. Okay, sorry, we can use a loop. We use a forever loop just to make sure that the robot moves infinitely until we stop the code. Okay, and then within the forever loop, we can put an if statement just to make sure that the robot doesn't move outside of the playing canvas or the playing field. Okay, so it will move, it will repeat the process forever. And we put a checkpoint here, which is we use a sensor to detect the border, okay, to make sure that the robot doesn't exceed the boundary. Okay, so we can use sensing. Go to the sensing block and check using the eye, okay, which like a vision. Okay, just select this one, put it inside this hexagonal area. Okay, now we instruct the robot's eye or its vision to make sure that it detects red. Okay, instead of using front eye, we use down eye. Okay, so it needs to detect red in order to make sure that it doesn't go overboard lah. Okay, so if this is detected, then there needs to be some instruction. What happens if the robot detects red? Okay, so in that case, we need to make sure that the robot still moves within the canvas. So just put a simple code here for it to move inside. Okay, so you can drive forward for perhaps uh, 20 millimeter or 30. You can adjust the numbers accordingly based on your preference. Okay, and then move randomly lah. So you can just put another one that instruct the robot to move another direction, another direction lah. Instead of forward, now we use reverse instead of forward. Okay, and then of course you want the robot not to move just forward and backwards. You need to make sure that it turns. Okay, so you just put a turning block here that instruct the robot to turn to a certain direction. Okay, for instance, let's say turn right for 90 degrees, or you can use any random angle, maybe 100 degrees. Okay, so that will allow the robot to move randomly inside the canvas if it detects red border. Okay, so that statement here will allow the robot to just stay within the playing field and not go overboard. Okay, what happens if it doesn't detect the red line? Okay, what it do, you can just make sure that it drives forward lah. Okay, so when that you can delete this stop driving because you want the robot to move infinitely. Okay, so you can go ahead and test if it's working. Okay, so I just start the simulator. Okay, you can see now the robot is moving. And it will, okay, you can see the highlighted area here. You can see the highlighted block. So whenever it's executing that block, it will highlight the block. Okay, so you can see that the robot is now pushing the blocks. Okay, of course, this will take time because the intelligence here in this process is not sophisticated yet. It doesn't have any decision-making capability that allows it to detect the blocks using certain sensors, but it's just moving within the area randomly and hoping that the blocks are pushed aside. Okay, so this will take time lah for the robot to push the blocks around. But over time, it will be able to push the blocks out. Okay, that's why we use a forever loop here to make sure that it loops within the playing area until as blocks have been pushed out of the uh, play. Duplicating that. Okay, duplicate again. add more randomness to the movement. Okay, change the angles. Okay, reverse and forward. And you'll be able to see more randomness to the movement. Okay, so this is an example of using the if statement as well as using the loop. Okay, so we repeat certain processes without us having to hard code the instruction. Okay, it just repeats whatever is within its bracket or within its boundaries. Okay, so we make sure that the robot just repeat certain instructions accordingly. Okay, so that's one example here. So this is the example on the castle. Okay, so please feel free to modify your code. Of course, this one is just a simple example. You can add more sensors in order to come up with a more sophisticated code. Okay, and you might achieve the objective way faster than the one that I've shown you earlier. Okay, so now let's move on to the next example, which is to draw a star. Okay, so again, this will require the use of a loop. Of course, if you refer to session number 1 just now, I have shown an example of how you draw a square or a triangle. But of course, you have to explicitly define each and every step of the process to draw a line. If you have 4 sides to the square, you need 4 separate sets of lines of codes in order to draw a single line. But in this case, if you use loops, you can actually shorten the code. Okay, because you can see some of the process is just a repeated process. It's just you need to change some details of the codes accordingly to make sure that it accomplishes the required task. Okay, so the objective here is to draw a star using a loop with number of blocks or number of steps less or equal to 12 steps. Okay, so that doesn't include the started and the stop code or the stop project. All right, so how do we accomplish this? Of course, we can use a loop. So the function of the loop here is to repeat the process of drawing a line. So you need to make sure that the robot moves forward and then it will turn at a specific angle and then repeat the process using the loop. Okay, so how do we accomplish this? Okay, let's try this one. Okay, again, open up the simulator. Okay, and I'll go ahead and close this one and open a new playground, which is the basic one, art canvas. Okay, and I will remove the previous code so that we can start fresh. Okay. So how do we draw a star here? Okay, so we have our starting point. So now we set the turn velocity to 100 and 900 and then the set drive to make sure that the robot move fast. Okay, so just delete this. Okay, and then we move the robot pen down to make sure that the robot now is drawing something on the canvas. Okay, where's the pen functionality? Set pen, move pen down. Okay, and then drive forward. So once we have put the pen down, we need to drive forward a certain distance So let's try 1,800, 1,000, sorry. Okay, and then once we have drawn a line, we need to turn, of course. In order to draw a star here, okay, we can turn the robot. Okay, turn 90 degrees. Sorry. But before that, we need to initialize the position first. So of course, we move the robot up, move the pen up first before we put it down. We need to initialize the position of the robot. Okay, so this is to initialize where it starts. So we drive forward for 100 millimeters, then we turn to the right hand side 90 degrees, and then we drive forward 600 millimeters. Okay, so at this point, we move the robot, move the pen down. Oops, sorry. Okay, move the pen down to make sure that the pen touches the canvas. Okay, then only we start our loop in order to draw the star. All right, so what we can do is select the, okay, we can use either a repeat. I think the most suitable one to use here is the repeat loop. And since the star has 5 lines, we repeat this 5 times. Okay, so each line will have us produce 2 line of codes. Okay, so what you can do here is you can set your pen color lah if you want. Set pen color to a certain color. Okay, let's say I choose here green. Okay, and then drive forward while your pen is down. And depending on the length of each of the line of the star that you want to have, specify the length. I put here 1,000 millimeters. And then the star would have an angle of 144 degrees between 2 adjacent lines. Okay, so turn right. So you have to turn right at a certain angle. Turn right for 90 degrees or 144 for a star. Okay, and yeah, that should be it. Okay, so the important part for you to observe here is the use of the repeat loop, okay, where we repeat the process 5 times, where each of the repetition will produce 1 line of the star. Okay, so let's go ahead and run this. Okay, you can see the initial, oops, sorry. Oh, there's something wrong here, in which we need to troubleshoot. Okay, let's see what's wrong with it. Okay, that means let's stop there. Okay, set drive 100, move pen up, then drive forward, turn right, drive forward for 600 millimeters, move pen down, set pen color to green, drive forward for 100 millimeters, and turn right for 140. Okay, let's initialize that. Move pen up, drive forward, turn right, drive forward. Okay, or maybe I can remove these lines of codes now. Okay, let's try again. Okay, now it's drawing. Oh, perhaps the distance is too big. Okay, that's why it's very important for you to make sure your distance is correct. Okay, let me draw just a small star instead of a big one. Okay, initialize, reset, and let's draw. Okay, now it's drawing the star. Okay, all right, and the star is green depending on our specification. Okay, so as you can see, each line is constructed using repetitions instead of many sets of codes. Okay, so if you don't use a loop, you need 10 or more lines of code. So in this case, we use only 1, 2, 3, 4, 5, 6, 7, 8, and 9 instead of a big number of lines of codes for you to construct the star. Okay, so if you go ahead and you perhaps change some specifications of the line, you can see that it won't produce a star lah, because the angle is not right. So let me just change this to 150 and see if this will work. Okay, so as you can see, still, it still look like a star, but of course it doesn't fully resemble a complete star lah. Okay, so that's why the details is important as well. Okay, so if you want a bigger star, of course you just change the size. Instead of 500, we use 700 instead. Okay, so now you're expecting a bigger looking star. Hmm, okay. Okay, so that's an example of usage of loops in order to simplify your code. Okay, so if we compare the time that you need um, for similar objectives but using different way of writing codes. Okay, so you can see that without repeating processes using loops, okay, you will be having more codes, um, and the complexity of the code will be increased as well. Okay, so that's why it's very important for you when you design your code, any part of the process or the code that is best to use loops. Okay, please use loops in order to simplify your code. Okay, and then we can also convert our blocks into text code. Okay, for if I'm not mistaken, this is written in Python. Okay, so this is what university students learn lah. We don't our students do not learn uh, writing codes using blocks. Okay, but they use actual syntax of the programming language to write the codes. Okay, but both of them achieve the same purpose lah. It's just that one is using textual code, the other one is using block code. Okay, so inside the simulator, you can also generate the code, the textual code. Okay, so just go ahead and click this sign here. Okay, on the right hand side, top right hand side of the simulator, and it will show you the corresponding codes for this series of block instructions. Okay, so it will give you the complete code, and you can actually edit it as well. Okay, you can convert it to a text project, and it will allow you to write the codes using textual code instead of using the block codes. Okay, so there you go. There you have the codes in textual form. Okay, where you can edit them accordingly, and as well as running them as what we have done earlier. Okay, so if you're comfortable working with the textual code, you can use the textual code instead. Okay, accomplishing the same task depending on the specifications that you have put on your textual code. Okay, you can change the color. Okay, given that the color is available. All right, so this is the textual code. Okay, for more advanced users, they prefer the textual code, of course. Okay, so let's move on. Okay, you can also convert block code to text code as I shown just now. Okay, just choose this symbol here and you can convert them into text code, and then you can open up a new project, okay, based on the text project. Okay, so that's the end of part two. We proceed with the session three after this. After we take a short break. Okay, more or less a 3 minutes break for you to refresh, and we'll start with session three after this. Okay, see you later.
Nak tahu kelajuan peranti pintar dalam 5G? Di MMU ada jawapannya. Nak tahu bagaimana kandungan kreatif dan perniagaan atas talian dikuasai? Di MMU ada jawapannya. Nak tahu bagaimana cyber security dan undang-undang berfungsi? Di MMU ada jawapannya. Semua itu dan banyak lagi ada di Multimedia University kerana MMU ialah anda menerajui masa hadapan digital. Layari mmu.edu.my.
Okay, welcome back. Hope you had fun with session one and session two. And session three will be a little bit more exciting and a little bit more advanced. Okay, we'll be looking at the use of electromagnet in VEXCode VR. Okay, so there is a functionality in VEXCode VR as well, where it uses magnet in order to attract metal, in order to pick up certain metal base stuff, okay, from the playing field. And in real world applications, this is also applicable in certain manufacturing processes where the robot is used to gather certain objects which are made using metal and pick them up and then place them somewhere else, okay, or pick and place robot lah, as in short, as we call them. Okay, so we can also use the same functionality in VEXCode VR simulator. And in this session, we're going to go through to see how we operate magnets, and then how we use sensors to detect discs and certain discs with specific colors, okay, including using down eye sensor of the robot. Okay, and then as usual, we'll be doing some exercises as well. Okay, so let's go through some of the introduction to the magnetic component of the robot for pick and place. Okay, so in terms of the block, we have one block which is known as the energized block, which is used to pick up certain objects, where it will attract a disc, a metallic disc, using the electromagnetic picking mechanism. Okay, and it has the ability to boost, to pick or to drop the object. Okay, so this is one block which is used to for us to add into our instruction for the robot in case we want to use it. Okay, so looking at the virtual robot, you can see that is underneath the robot here. Okay, and as you can see here, okay, in the middle there, that's the pen that we have been using in exercise one, session one and session two. Okay, so let's look at the small demonstration now, how to use the sensor to attract this and put it in the box. Okay, so we can start by looking at this series of instructions, where we are required to pick up certain discs of a specific color. Okay, for instance, step one is to drive the robot to pick up blue disc. Okay, for instance, we drive the robot with a certain distance of 750 millimeters, and then we pick up the first blue disc. So in that instance, we need to specify an energized block, or we need to include the energized block where the magnet will be used to boost or to pick up a disc, a blue disc. Okay, and then we move and then after it has picked up, it has to drop the disc at a specific location. Okay, so we specify that the robot drive in reverse mode for the same distance, which is 750 millimeters. Okay, so what happens is the robot will move forward, pick up the disc, and then move backwards, reverse. Okay, and then it drops the blue disc in the blue goal or blue area that is specified on the playing field or the canvas. Okay, so we have to choose drop instead of boost. Okay, and the next one is how to use the down eye sensor to detect this, then to pick up. Okay, so first of all, we need to set up the sensor. So we repeat. Okay, if you are familiar with this, we have covered this in session number 2, which is a loop that repeats a certain process. Okay, so it repeats until the front eye detects an object and then it moves forward. Okay, so this is setting up the sensor. Okay, and then this part here is to change the front eye, whether it's a down eye or front eye. Okay, front eye meaning it detects in a forward mode, so it looks what's in front of it. Okay, down eye is where it detects what's underneath the sensor, what's underneath the robot. Okay, and then we can also specify what object the front eye or the down eye is supposed to detect. Okay, in terms of colors, so in this case we specify a red. Okay, we have 4 options: red, green, blue, or none. Okay, none, it will detect any object lah without the color specified. Okay, and then after it detects, it drives forward. Okay, so this is using the down eye or the front eye sensor to detect certain colors. Okay, so looking at the code, after the robot has detected an object using the down eye, and then it drives forward. Okay, after it detects the object, it drives forward. Then what after that? Okay, so we need to make sure that whenever it detects the object, it needs to do something. So we can actually repeat the process. Okay, and then using the down eye again, we check whether the robot again detect an object nearby to it, and then it stops driving. After it detects the object, then only it will use the magnet to pick up the object. Okay, so there are 2 steps here lah. First of all, it will repeat until it finds the object. After it finds the object, then it picks up the object. Okay, and then we also have the distance sensor. So the distance sensor will specify, or we can use it to specify the distance between the object and the robot. Okay, meaning that the sensor is actually in front of the robot, and the code that we can see here is a code that we can use to trigger the front sensor to measure a specific distance, meaning that once the robot is able to detect an object, it will be able to get an input as to how far is the robot. Okay, and we can use a wait condition. Okay, it will wait until a specific distance which is specified, then it will only do something. Okay, later on we'll see an example of how to implement this lah. Okay, meaning at the distance here we can set it to be larger than, okay, the distance should be larger than 50, or the distance should be smaller than 50, or is exactly 50. Okay, and then we can specify the distance in millimeter. Okay, the distance in millimeter should be less than a certain number. Okay, we can set that depends on our situation lah. Okay, depending on the ecosystem of the playing field that we want to work on. Okay, you can also, instead of millimeter, you can also use inches if you want. Okay, and then of course at the end, we stop the timer in the playground. Okay, go to the control block, select stop project, then put the block at the end of your block code to make sure that you tell the robot that this is the final part of the instruction. Okay, and the timer will stop after your block code is completely executed, or else it will not stop. Okay, so it's best to look at an example of how to use the sensors here. So we have this playground known as this mover, and we have different blocks: blue block, we have a red block, and we have the green block. And you can see that there are discs with different colors specified. Okay, and the box is a square shape. You can think of it as a goal lah. You need to pick and place the disc into the goal or into the box, and each of these block measures 200 millimeters on each side. And you can see here, okay, later on I'll show this in the simulator, that the distance displayed at the playground is measuring the distance between the front sensor and the wall facing the front sensor. Okay, you can see here the distance here, 1745 millimeters. This distance is the distance between the front sensor, okay, of the robot and the wall facing the front sensor, which is this particular wall here. Okay, so you can see it's 1745 millimeters. Okay, so when you place the sensor or when you specify the sensor, all these readings will appear. Okay, you can also indicate whether there's a detection of this, okay, using the front eye, using the down eye, and also the location of the robot. Okay, so let's try one exercise here, where the objective and the goal of the exercise here is to place all the blue discs. Okay, so here we have 3 blue discs, and place them into the blue box. Okay, place all the blue discs in the blue box using the simplest way of coding, using the simplest coding sequence. Okay, and as an advisory, you are encouraged to use repeated codes. Okay, meaning using loops lah, and set the number of loops accordingly. Okay, so that's the exercise number 1 here. Okay, so of course we can try that together. And as usual, let's open up the simulator and open a new playground. Okay, select a playground and select the this mover playground, and it will load. Okay, We just close this. Mm, Okay, I'll just reload the whole thing to go back to the block mode. It's not. Hold on, yeah. Okay. Okay, open up the playground, this mover. Okay, now the playground has been loaded. Okay, let us start with the code. So now again, remember the objective is to move the blue disk into the blue box or the blue colored goal by moving the robot and picking up all the blue disks and dropping them into the blue box. Okay, so we can start by having a repeat block. Okay, we repeat 3 times. Okay, then we use our down eye sensor. Okay, so we have to repeat again, repeat until a repeat until block here, a C block, and our sense is supposed to detect blue disk. Okay, so we use a front eye sensor or down eye sensor. Okay, we use down eye because it is required to detect the presence of a disk. Okay, and it's a blue. Then we use a down eye. Okay, and then we drive forward. Okay, so once it detects blue, repeat until, meaning that it will repeat driving forward until it detects a blue disk using the down eye sensor. Okay, so you can imagine that the robot will move forward and it will repeat the process until it detects the blue disk. Okay, so that's why we use a repeat loop to make sure that the robot performs an action which is driving forward until, meaning that it will stop until it detects the blue disk. Okay, so once it detects the blue disk, then it needs to do something. And what is that? Okay, first of all, of course, it needs to stop driving. Okay, so once it detects the blue disk, how will we make the robot pick up the disk? Okay, so that is the point where we have to use our magnet. Okay, so we energize our magnet here and request it to pick up. Okay, pick up here means to boost lah. Okay, so once it has stopped and pick up this, then what does it need to do? The robot needs to reverse or it needs to turn and move forward. Okay, so it depends on your preference. Okay, so let's say you want it to turn lah. Okay, so turn um turn to rotation. So because you want it to turn to the and then it drives forward again towards the blue light. Okay, so now we have the first cycle, detect the blue disc, pick it up, turn back, and return in the blue box. Then after it has returned in the blue box, what does it need to do? Okay, it needs to make sure that it, first of all, of course, we need to make sure that it returns into the blue box. So how do we make sure that it returns into the blue box? Okay, so we must make sure that the distance between the robot and the blue box is correct. Okay, so we can set up another loop. Okay, we can use the wait until loop. Okay, using wait until. Put it there. Okay, and then set the distance. Sensing. Location. Sorry. We'll put a green one first. Operator. Okay, let's say we set this to 150 lah. Okay, and then put a distance either in inches or in millimeters. Okay, this one. Millimeters. Okay. Then we set up the next part. Okay, where we drop the sensor and we drop the disc. Energize and drop, and then turn to heading 0 degrees. Okay. Okay, so we can try this out and see if it's working. If it's not working, then we need to troubleshoot as usual. Okay, just execute this. So it stops there. Oh, there's a bug. So we need to fix it. Okay, initialize, reset. Okay, so that's one part which is not working. So at the point where it turns 180 degrees, then it moves forward and waits until a certain distance. Oh, okay. I think this one's supposed to be below, smaller than 150, not 150. We have to change that accordingly. Okay. All right. So let's see if it's working now. This one is 150. Okay, picks up the first one. Return back. Oh, it's not picking up. So there's something. Oh, it's picking up. The first one doesn't pick up. Okay, detects and pick up. Return to the blue box and drop. Ah, so there's one more step. Check the forward. So again, we troubleshoot as usual. Nice drop. Okay, we can also change this to 4 if we want to. And see if it's working this time. Or the first round it doesn't pick up. Second round it picks up. Okay. Okay, so this example shows how the robot can be utilized to pick up the blue disc. Okay, of course you can make some modifications as well to have it pick up the red ones instead of the blue, and accordingly the green ones. Okay, so this shows how we can use some of the sensors to detect different objects, okay, in the canvas. Okay, where it uses a combination of loops, repeated processes, and then some sensors, and of course distance sensors as well. Okay, to make sure that the robot place the disc at its specified location. All right, so this is one example of how this can be used to program the robot. Okay, so for session 1, session 2, and session 3, we have seen how we can use a simulator to program different different robots for different objectives and different purpose. And you can also explore the other playgrounds. Okay, for instance, we have this rover rescue playground. Okay, let's wait for it to load. Okay, there are many interesting playgrounds that you can experiment with, and each of them require different tasks for you to fulfill. And you can actually run your codes or construct your codes accordingly based on the different playgrounds. Okay, this one will take a bit to load because of the um, sophistication of the playground. There you can see, and it has several other functionalities as well, where you can see a map of the location of the robot. Okay, if I expand this, okay, so you can also see other more advanced functionalities, where it shows you certain distances between the robots and certain objects. And if I run this one, okay, it already has some pre embedded codes inside. Okay, and you can also change the view if you want to, and you can see different aspect of the environment. Okay, so this one will not be covering today, so I hope you can explore this on your own, because there's a lot of exciting playgrounds for you to play with. Okay, and there's quite a lot of them. So this one is just the free version. Of course, there's a paid version where you can explore more other playgrounds as well. Okay, so I guess that's where we come to the end of the session today. So again, as I mentioned earlier, the most important thing when it comes to the design of robots, you need to know about the mechanical component of a robot, and you also need to know, similarly important, which is the programming side of a robot, for you to give the robot instructions, so that the robot knows what to do. And robotics is the way forward now, because there's a lot of processes in various industries where automation plays an important role. And for automation to play its roles, of course, the basic ideas, basic concepts of robotics is also important, okay, for students to know. And I hope the session today is useful for everybody, at least to give you an idea of what robotics is and how to start learning robotics. So this is just a starting point. Of course, in our programs in the university, our students learn more than just using blocks. Of course, you need to know how to program robots, hardware programming, to make sure that the robots are given proper instructions for them to complete certain tasks. Okay, so thank you very much, everybody. So I hope everybody have a enjoyable time and you get a basic idea of how to use the VEXCode VR simulator to play around and to come up with your own codes to accomplish the task. Okay, so if you have any questions, I think can also be. Are there any questions? Yeah, I guess there's no question. All right. Again, thank you very much, everybody. And for school kids are on holiday, enjoy your holiday, enjoy your break, and have a good day. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Nak tahu kelajuan peranti pintar dalam 5G? Di MMU ada jawapannya. Nak tahu bagaimana kandungan kreatif dan perniagaan atas talian dikuasai? Di MMU ada jawapannya. Nak tahu bagaimana cyber security dan undang-undang berfungsi? Di MMU ada jawapannya. Semua itu dan banyak lagi ada di Multimedia University kerana MMU ialah anda menerajui masa hadapan digital. Layari mmu.edu.my.